My dear students, in this video, I am going to introduce the topic finding the inverse of a given matrix by Gauss-Jordan method. We have to find out the inverse of a given matrix, square matrix A, by Gauss-Jordan method. Gauss-Jordan method means transforming a non-singular matrix A into identity matrix. We have to transform the given square matrix A into identity matrix by applying elementary row operations. Is called Gauss-Jordan method of finding the inverse of the given matrix A. So Gauss-Jordan method is nothing but transforming a non-singular matrix A into identity matrix by applying elementary row operations, and that method is called Gauss-Jordan method of finding the inverse of a given matrix. Non-singular matrix means the determinant value of a matrix should not be 0. If the determinant value of a matrix A is 0, then the matrix A is called singular matrix. A is a singular matrix. If the determinant value of A is not equal to 0, then the matrix A is a non-singular matrix. This is the definition of singular and non-singular matrix. When will you say that a matrix is said to be singular means if the determinant value of A is equal to 0, then the matrix A is a singular matrix. If the determinant value of A is not equal to 0, then the matrix A is called a non-singular matrix. So if the matrix is a non-singular matrix of order 3, then we have to convert the same matrix A into its corresponding identity matrix of order 3 by applying the elementary row operations, and thereby we have to determine the inverse of the matrix A. That method is called Gauss-Jordan method. See, we have to solve one problem now. We are using elementary row operations only. Now, consider this problem. Find the inverse of the matrix A. Find the inverse of the matrix A. 2 minus 1, 5 minus 2. You have to find out the inverse of the given matrix A by Gauss-Jordan method. By using Gauss-Jordan method, we have to find out the inverse of the matrix A. For this, our first step is we have to augment this matrix A with its corresponding identity matrix. That is, this is called augmented matrix. Augment the matrix A with the corresponding identity matrix. Since it is of order 2, we have to augment this matrix A with the identity matrix of order 2. That is 2 minus 1, 5 minus 2, 1, 0, 0, 1 is the identity matrix of order 2. We have to augment like this. And by applying elementary row operations, we are converting this matrix A into identity matrix. Thereby this matrix becomes inverse of matrix A. So it is of the form, from this by applying, it becomes I into A inverse. After augmenting the matrix A with I, we transform this A matrix into identity matrix by elementary row operation. This matrix becomes A inverse. That is our idea. So for that, our first element should be always 1, 1, 0, 0, 1. We have to convert this 2 into 1. 1, 0, 0, 1. We have to convert. For that, to convert this element 2 by 1, we have to divide the first row by 2. R1 is divide R1 by 2. So what do you get? 2 by 2 is 1, minus 1 by 2, 5 minus 2. You keep as it is and divide the corresponding first row elements by 2. 1 by 2, 0 by 2 is 0, 0, 1. This is our first idea. Okay. Now 1 0 0 1, we have to convert this 5, the element 5 by 0. For that you convert R2 becomes R2 minus 5 R1. You multiply R1 by 5 and subtract from R2, you will get this element becomes 0. So that see R2 is R2 minus 5 R1. R2 is R2 minus 5 times of R1. 5 times of R1 is 5 is 5. 5 minus 5 R2. So first row you need not change first row. 1 minus of as it is. Second row you have to convert R2, subtract, multiply R1 by 5 and subtract. 5 1 is 5. 5 minus 5 is 0. And 5 times of R1, R2 is minus 2. R2 is minus 2. 5 times of R1 is minus of minus. Minus 5 times of R1 is minus 5 by 2. That is minus of minus plus 5 by 2. That is 2 minus 4 plus 5, that is equal to 1 by 2. So this minus 2 becomes 5 times of minus 5 by 2 minus of minus plus 5 by 2 minus 2. This is 4. 5 minus 4 is 1 by 2. And the second one, first row you correct as it is 1 by 2, 0. 5 times of R2, R1, R2, 0 minus 5 by 5 times of R1 is 5 by 2, 0 minus 5 by 2 is minus 5 by 2. And 1 minus of 5 times of R1, 5 times of R1 is 0, 1 minus 0 is 1. That's all. Next, again, you just add 1 0 0 1. So you multiply, you just add R1 by R2. The next step, R1 is R1 plus R2. R1 is R1 plus R2. For that, R1 plus R2, 1 plus 0 is 1. Minus 1 by 2 plus 1 by 2 is 0. Second row as it is. First row only you have to convert. R1 is R1 plus R2. 1 plus 0, 1. Minus 5 by 2 plus 5 by 2 is 0. Similarly, R1 plus R2. 1 by 2 minus 5 by 2. 1 by 2 plus minus 5 by 2 is 1 by 2 minus 5 by 2. That is 5 minus 1, 4 by 2. 5 minus 4 by 2 is minus 2. Minus 5 minus 1. 5 minus 4 by 2 is minus 2. Similarly, R1 plus R2, 1 plus 0 is 1. 1 plus 0 is 1. Second row, you convert as it is. Minus 5 by 2, you write as it is the second row. First row only you have to change by adding R1 and R2. Now, second row, the first element, the second row, second element becomes, second column will become 1. Therefore, you have to multiply R2 by 2. R2 is 2 into R2. 2 into half is 1. Therefore, you multiply R2 by 2. 1, 0 as it is. 2 into 0, 0. 2 into 1 by 2, 1. And minus 2, 1 as it is, you write. And multiply R2 by 2. Minus 5 by 2 into 2 is minus 5. 1 into 2, 2. So it's become identity 1 0 0 1. It becomes I minus I2, I 1 0 0 1 into A inverse. Therefore A inverse is this. Matrix is A inverse. A inverse is minus 2 1 minus 5 2. So A inverse is minus 2 1 minus 5 2. Therefore answer for A inverse is the right hand side matrix minus 2 1 minus 5 2. That's all about the inverse of the given matrix A. So augmenting the matrix A with the corresponding identity matrix I2, applying elementary row operations, you will get I into A inverse. I into A inverse will become, we convert this step and we convert this first element A into its corresponding identity. Therefore, the other element, other matrix becomes A inverse. Therefore, A inverse is minus 2, 1, minus 5, 2 is the A inverse of the matrix A. This is the method of finding the inverse of the given matrix. This method is called Gauss-Jordan method. It is a 2 by 2 matrix. Now, next I am going to solve one more problem, 3 by 3 matrix, by converting 3 by 3 matrix into its inverse by Gauss-Jordan method. We will see. Next problem. Find the inverse of say second sum. This is second sum in the third subdivision of your exercise. Find the inverse of A equal to 1 minus 1 0, 1 0 minus 1, 6 minus 2 minus 3. You have to find out the inverse of this matrix A by using Gauss-Jordan method. Now you augment this matrix A with the corresponding identity matrix. It is I3. Therefore, it becomes 1 minus 1 0, 1 0 minus 1, 6 minus 2 minus 3, 6 minus 2 minus 3 with the identity matrix 1 0 0, 0 1 0, 0 0 1, I3. Now, by applying elementary row operations, you have to convert this matrix into A matrix into identity, and thereby this matrix becomes the inverse of the given matrix. So first element should always 1. Already there is 1 here, therefore no problem. Now you convert this element to 0, or R2 is R2 minus R1. 1 minus 1 0. This becomes 0 when 1 minus 1 is 0. R2 minus R1. So here R2, I am going to convert R2 into R2 minus R1. Similarly, R3 into R3 minus 6R1. R3 minus 6 times of R1. 6 times of R1 is 6 minus 6 is 0. So that you will get the problem as 1 minus 1 0. R2 is R2 minus R1. 1 minus 1 0. 0 minus of minus 1 plus 1. Minus 1 minus 0 minus 1. Next, R3 minus 6 times of R1. 6 minus of 6 times of R1 is 6. 6 minus 6 is 0. Minus 2 minus of minus 1 minus times 6 times is plus 6. So minus 2 plus 6 is 4. And 6 times of 0 is 0. Minus 3 minus 0 is minus 3. 0 4 minus 3. Now 1 0 0 you convert. You write the first row as it is, second row, or this is a corresponding operation you have to match this matrix also. For that R2 minus R1, 0 minus 1 is minus 1, 1 minus 0 is 1, 0 minus 0 is 0. Second idea, R3 minus 6 times of R1, 0 minus 6 times of R1 is 0 minus 6, 0 minus 0, 6 times of 0, 0, 1 minus 0, 1. So this is our first step. Next, if you add these two, this element becomes 0, because you have to convert this into identity matrix. For that, this element becomes 0. For that, R2 plus R1. Next, you R2 plus R1. R2 is 1 minus 1. R1 is R2, R1 plus R2. R1 plus R2. 0 plus 1. 1 minus 1, 0, minus 1 plus 0, minus 1. Okay. Next, 0, 1, minus 1, 0, 4, minus 3. R1 plus R2, 1 minus 1 plus 1, 0, 1 plus 0, 1, 0 plus 0, 0, minus 1, 1, 0, minus 6, 0, 1. What I am operating here is R1 is R1 plus R2. In this step, I am adding R1 and R2. R1 plus R2. R1 plus R2. R1 is R1 plus R2. Minus 1 plus 1, 0. 1 plus 0, 1. 0 plus 0, 0. So, this is R1, adding R1 and R2, I am writing into the row R1. And then the next step, this, if you multiply R2 by 4, 4 minus 4 is 0. This element becomes 0. R3 is R3 minus 4 R2. Next idea is see, R3 is R3 minus 4 R2. R3 is R3 minus 4 R2. So R1 is not altered. You write R1 as it is 1, 0, minus 1. R2, R3 we have to change. R2 is also, you write as it is 0, 1, minus 1. And 0, R3 minus 4 R2. 0 minus 4 R2 is 0. 0 minus 0, 0. R2, 4 R2 is 4 into 1, 4. 4 minus 4 is 0. And this is minus 4 into 1, minus of minus plus 4. Minus 3 plus 4, 1. Okay. Next here also in this stage, 0, 1, 0, first row as it is. Second row is also, you are right as it is minus 1, 1, 0. And third row R3 is R3 minus 4 R2. R3 is minus 6, 4 R2. Minus or minus plus 4. Minus 6 plus 4 is minus 2. And 0 minus 4. Minus 4. And 1 minus 0, 1. Minus 2, minus 4, 1. After operating this R3, you will get this equation. Next. Now you have to R1 plus R3. If you add R1 plus R3, this becomes 0 because 1, 0, 0 you want. For that, R1 is R1 plus R3. R1 plus R3, this element becomes 0. And one more operation, R2 is R2 plus R3. Yes. R2 is R2 plus R3. R1 is R1 plus R3. R2 is R2 plus R3. So what do you get? R1 plus R3. R1 plus R3. 1 plus 0, 1. 0 plus 0, 0. Minus 1 plus 1, 0. R1. Similarly, R2 plus R3. R2 plus R3. 0 plus 0, 0. 0 plus 1, 1. Minus 1 plus 1, 0. 0, 0, 1. So it becomes an identity matrix. The next here, first row 0, 1, 0 as it is. Oh, sorry. R1 is R1 plus R3. R1 plus R3, 0 minus 2, minus 2. 1 minus 4, minus 3. 0 plus 1, 1. R1 plus R3, 0 minus 2, minus 2. 1 minus 4, minus 3. 0 plus 1 is 1. Similarly, R2 plus R3, R2 plus R3, minus 2, minus 1, minus 2 is minus 3, 1 minus 4 is minus 3, 0 plus 1 is 1, and R3 as it is you write minus 2, minus 4, 1. So this is an identity matrix, therefore this is of the form I into A inverse, therefore A inverse is this. So the given A inverse of the given matrix is, you have determined what is that? A inverse is minus 2 minus 3 1, minus 3 minus 3 1, minus 2 minus 4 1. This is the inverse of the given matrix A. That's all about that. Minus 2 minus 3 1, minus 3 minus 3 1, minus 2 minus 1. This is the inverse of the given matrix A. That's all about the Gauss-Jordan method of finding the inverse of the 3 by 3 matrix. Okay. We will see one more problem. It is also in the given in your textbook. What is that? It is also a 3 by 3 matrix. We will see. I erased this sum, and one more sum I am going to solve Gauss-Jordan method of solving the inverse, finding the inverse of a given matrix of order 3. So given matrix is, matrix A is, I will write the sum here. This is a matrix A. Given matrix A is what? 1 2 3, 2 5 3, 1 0 8, 1 2 3, 2 5 3, 1 0 8. We have to find out the inverse of the matrix, non-singular matrix A by Gauss-Jordan method. You augment this matrix A with the corresponding identity matrix I3. So A into I, that is I3, is equal to A is 1 2 3, 2 5 3, 1 0 8, augmented with the corresponding identity matrix. Corresponding identity matrix 1 0 0, 0 1 0, 0 0 1. Okay. Now already the first element is 1. You have already 1. Therefore, R3 minus 2 R2. R3 minus 2 R2. If you write this becomes 0. R3 minus R2. R2 is R2 minus 2 R1. R3 minus R1. These two operations simultaneously you write. If these two elements become 0. To convert this element 2 into 0, you subtract R2 from 2 times of R1. If you multiply 1 by 2, 2 minus 2 is 0. This element becomes 0. Similarly, R3 minus R1, 1 minus 1 is 0. To convert these two elements into 0, first operation is R2 is R2 minus 2 times of R1, and R3 is R3 minus R1. These two ideas simultaneously you have to apply here. First, R2 minus 2 R1. R1 as it is you write 1, 2, 3. R1 is nothing altered. R2 is R2 minus 2 times of R1. 2 minus 2, 0. 2 times of R1, 4. 2 2s are 4. 5 minus 4, 1. 2 times of 3. 3 minus 6. 2 3s are 6. 3 minus 6, minus 3. Similarly, R3 minus R1 minus 1, 0. 0 minus 2, minus 2. 8 minus 3, 5. 8 minus 3, 5. Okay. Similarly, the first row 1 0 0 you write as it is. R2 minus 2 times of R1. 0 minus 2, minus 2. 1 minus 0, 1. 0 minus 0, 0. R3 minus R1. 0 minus 1, minus 1. 0 minus 0, 0. 1 minus 0, 1. Okay. Next, R1 plus R3. R1 plus R3. You see, 2 plus 2 minus 2, 0. This becomes 0. If you add R1 plus R3, these two become 0. So R1 is R1 plus R3. For that, see, R1 is R1 plus plus R3. 1 plus 0, 1. 2 minus 2, 0. 3 plus 5. R1 plus R3 plus 5, 8. And the second row 0, 1 minus 3 as it is. 0 minus 2, 5 you write as it is. And here R1 is R1 plus R3. R1 plus R3. 1 minus 1, 0. 0 plus 0, 0. 0 plus 1, 1. Minus 2, 1, 0. Minus 1, 0, 1. I write as it is. Okay. Okay. R3 plus 2 R2. If you R3 plus 2 R2, if you add R3, this element becomes 0. R3 plus 2 times of R2, if you add these two, this element becomes 0. Therefore, R3 is R3 plus 2 R2. R3 is R3 plus 2 R2. For that 108. R3 we have to change, therefore R2 is as told you write as it is. R3 plus 2 R2, R3 plus 2 R2, 0 plus 2 R2, 0 plus 0, 2 times of 0, 0. R3 plus 2 times of R2, 2, minus 2 plus 2, 0. 5, 2 times of R2, minus 6, 5 minus 6, minus 1. Similarly, 0, 0, 1, second row minus 2, 1, 0 as it is. R3 plus 2 times of R2. R3, 2 times of R2. Minus 2, minus 1, minus 4, minus 5. This is minus 5. Because R3 minus 1, 2 times of R2 minus 4, minus 1, minus 4, minus 5. 0 plus 2 times of R2, 2. 1 plus 2 times of R2, 1. So minus 5 to 1. R3 plus 2 R2. The next R2 minus R2 minus R2 minus 3 R3. R2 becomes 3. R3 multiplied by 3, and if you add it R2 you will get 0. R2 is R2 minus 3 R3. That's our next idea. Our next idea is we have to convert this element 1 0 0 0 1 0 to make this element to 0. R2 minus 3 becomes 0. R2 is equal to R2 minus 3 R3. Up minus or minus plus R3 and minus 3 0, it becomes 0. So our idea is R2 is R2 minus 3 R3. Minus 3 R3 means minus or minus plus. So R2 is changing. R1 108 as it is. R2 minus 3 R3, 0 minus 0 0. 1 minus 3 times of R3, 1. Minus 3 minus of minus R3, 3 R3. Minus of minus plus 3 minus 3, 0. And 0 0 minus 1. Here also zero zero one R2 minus 3 R3. R2 minus 3 R3. 3 R3 means 3 times of 15. 3 5s are 15. R2 minus 2. R2 is minus 2. 3 times of R3 means the 15 minus plus 15. 15 minus 2 is 13. So this becomes 13. Minus 2 plus 15 is minus plus 13. R2 minus 3 times of R3 minus 6. 1 minus 6 is minus 5. 1, 3 times of R2 is 6, 1 minus 6 is minus 5, and 0, 3 times of R1, R3 is 3, 0 minus 3, minus 3, and minus 5, 2, 1, you write as it is. So this is our next idea. Then this becomes 0. For that, how do you get? R3 is 8 R3. R3 is 8 R3 plus R1, or R1 minus 8 R3. See, here you have to convert this element to 0. For that, R3 is R1. So R1, it becomes 0. That R1 is R1. You convert R1 is R1 minus 8 R3. R1 minus 8 R3. Minus or minus 18 plus 8. R1 minus 8 R3. 0, 1, 0, 0, 0. Here 6. R1 minus 8 R3. Minus R1 is 8. R1 plus 8. 8 R3 is minus 8 plus 8 is 0. So this is 1, 0, R1, 0 into 1, 0, 0, 0, 0, R1 is 8, plus 8 R3 is minus 8 is 0, and 0, 1, 0, 0, 0, minus 1. Sorry. And this is R1. Minus 8 R3. 8 R3 is 8, minus 8 plus 8. 8 5s are 40. Minus 40. 8 5s are 40. Minus 40 plus R1 is 0. 40. Similarly, R1 0. 8 plus 8. 8 2s are 16 plus 0. 16. And 1 plus 8 R3 is 8. 8 plus 1 is 9. So 8 5s are 40, minus 8 into minus 5 into 8 is minus 40, 8 2s are 16 plus 0 16, R3 is 8, 8 plus 1 is 9, and 13 minus 5 minus 3, minus 5 to 1. Now you convert this element to 1. For that you have to multiply third row by 1, minus 1. Multiply R3 by minus 1, we will get the answer. R3 is multiply R3 by minus 1. For that 1, 0, 0, 0, 1, 0. If you multiply by minus 1, minus 1 to 0, 0, 0, minus to minus plus 1. Here minus 40, 16, 9, 13, minus 5, minus 3. Multiply by minus 1, you get plus 5, minus 2, minus 1. So this is an identity matrix of order 3. So this is the inverse of A. So it is of the form I into A inverse. Therefore, the inverse of the given matrix is the right hand side matrix. Because this is an identity matrix, therefore the A inverse of the required matrix is minus 40, 16, 9, 13, minus 5, minus 3, 5, minus 2, minus 1. This is the inverse of the given matrix. That's all about the problem. So, this is the Gauss-Jordan method of finding the inverse of the given matrix using what is that identity idea. Converting given matrix A into its identity matrix by transforming the only row operations. That's all about the method. I will stop the video here. We will continue the lesson in the next video. Thank you.